Hello there, welcome back to Hydroponics Daily, your go-to podcast for everything soilless cultivation. I'm your host, Dr. Russell Sharp, and today we're going on a trip back to the 1980s because we're talking about acid rain and its effects on plant health. So it hit the headlines in the 1980s, acid rain, but it still matters today. We'll look at what it is, why it forms, and how it affects plants, where and when it has occurred, and finally, why you need to be keenly aware of the issues with acid rain, even if you're growing indoors, especially if you're using foliar sprays. So we'll talk about that. Acid rain is not just rain, but it can be snow or even fog that has been acidified by air pollution. Normally, rainwater is slightly acidic anyway, and it can be up to around pH 5.6 because carbon dioxide in the air dissolves to form a weak acid called carbonic acid. But when sulfur dioxide and nitrogen oxides from burning coal, oil and gas, whether that's in a factory, a home or traffic, mix with the water in the atmosphere, they form much stronger acids, sulfuric acid and nitric acid. If you've ever used nitric acid in a lab, you'll know it is effing, insert expletive here, horrible, wicked, evil. It's one of the just really horrible acids, so you really want to avoid. Sulfuric acid is not particularly nice either, but nitric acid is really bad. And those two combined pull the rainfall pH down below 4. And in some cases, that makes it 10 to 100 times more acidic than normal rainwater because pH is a logarithmic scale. So what does rainwater that is 100 times more acidic actually do to your plants? Well, direct injury. So acid droplets on the leaves can leach away the protective waxy cuticle and cause browns, patches or necrosis. So normally leaves are covered, certainly the upper surface is covered with a waxy cuticle. Even if you don't think of it as being a waxy leaf, like a fig leaf or something like that, or an ivy leaf, they still will have wax normally on the cuticle to prevent excessive evaporation and to prevent damage, and acids will dissolve this. It'll also disrupt nutrients, so acidic water washes calcium particularly, but also magnesium and potassium out of the leaves and soils. Those are essential nutrients for growth, so plants become weaker. And then soil chemistry. In soil-based systems, acid rain mobilizes toxic elements like aluminium, which can damage roots and block nutrient uptake. And then there's the indirect stress. Plants under nutrient stress are more vulnerable to disease, pests and drought. The mycorrhiza won't like it either, so that's also something to consider. So it's rarely just burning the leaf. It's more about long-term nutrient imbalances, particularly calcium. So when and where has it occurred? Acid rain was most notorious in the 70s and 80s in Europe and North America, especially downwind of coal-burning power plants. Forests in Germany's Black Forests, lakes in Scandinavia, ecosystems in the northeastern United States were badly affected, I think around Los Angeles particularly. International agreements like the Clean Air Act amendments in the US and similar policies in Europe reduced sulfur dioxide. Flipping heck. That, my friends, is a government alert on my phone. Well, thankfully that was just a test, and there are no nuclear bombs or power plants exploding anywhere near me. So, yeah, thanks for that, UK government. You've just ruined my podcast. So where was I? I was in the northeastern United States, and they were badly affected, but clean air laws have been passed. So acid rain has declined since the 1990s, just like the ozone hole is repairing itself thanks to the Montreal Protocol, the effects that were brought in there. That said, it's still an issue in parts of China and India. So those hydroponic farms we talked about, or those farms we talked about yesterday, could be still suffering from acid rain, especially where coal is a major source. So now, what's this got to do with hydroponics? Well, you might get some acid fog coming in through your inlet filter, but the main one is telling you to avoid acidic foliar sprays. There are a lot of products on the market there that say can also be applied as a foliar spray if diluted. And these products have got pHs of 1 or 2, things like this, really acidic products. A lot of them are like propagation starting fertilizers that you think would be really gentle and good for your plants. A lot of 1 part fertilizers, obviously not liquid gold, or as it's called in the US, gold leaf, our product. That's a 1 part fertilizer that's always at the sweet spot for pH. So it can be used as a foliar with no issues. But if you've got any product that is really acidic, do not put it on your leaves, because it will strip the calcium off them and you'll get all sorts of issues resulting from that really weak, horrible growth that is highly susceptible to attack by pests and diseases, not least, and will die at the first environmental stress that they're given. If in doubt, just do a quick pH test on any foliar spray you're about to put on your plants. Most people only put foliar sprays on in vegetative phase anyway. So, to sum up, acid rain is a product of industrial pollution and the formation of nitric and sulfuric acid, but it can also be mimicked accidentally by the application of acidic foliar sprays. So be careful out there. Don't be putting any foliar sprays on that are too acidic. As always, my final request is that if you found any value in today's episode, please, 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 I'm begging you, go and do an Apple podcast review, because it shoots us up the charts. And I want to get as high as possible, because I want hydroponics to be in the top 10 of gardening and science podcasts in the UK, US and elsewhere, because then it'll just snowball from there and people will share it and find it much more easily. So thank you very much for listening. I'm off to exhibit at a trade show for lawn care, which will be fun. That will be 5,000 middle-aged white men, most of them bald, standing around talking about grass. Fan-dabby-dozy. See you tomorrow. Goodbye.